you
not like that.
yeah, you have to come up with what your z's will be. 1, -1, 0, 2.
I meant the, if you go back to the contour curves.
No. You don't have to color code it.
No,
But it should be parabolas.
For the z not equal to 2, you draw a gradient line or something like that when it's.
No. Don't worry about that. You just don't include it. Or you can put like a dotted line in there if it falls on your scale. If you're going by 1, 0, 1, 2, just put a dotted line for not existing is equal to.
Exactly.
Yeah.
Okay.
Let's plot this other one real quick here. Let's see. So that's the 2x over 3x plus 5y. This is the Mohawk graph.
Mohawk? Look at the damn thing.
There are my level curves. See them? We already said the level curves are lines. There they are. Now what's interesting is, let me see if I can orient this right. Oh, geez. This should be fun. I think this is really new. They haven't figured out. There, okay. Oh, that's exactly backwards.
That hurts my head.
You'll be all right.
Think of like a bow staff going around.
Damn, still backwards.
So the point where your hand
Yeah, that would.
All right, don't watch this for a second.
is, that would be the crown. That would be the calf of the stick.
All right, I've almost got it. Almost.
And some
Shoot. All right, so obviously I'm still learning. Okay. Freak. So what I'm trying to do is I'm trying to look at it. We're looking at it basically from below, so I can have all the. What time is it? Oh, don't worry. We'll get out a little early. Okay. Don't freak out. We're getting out a little early today. I'm trying to look at it from below so I can kind of line it up with the XY plane. These are my contour curves here, and of course you're figuring out already that they're straight lines. What do you think this is here? And of course, this graph can't really capture the whole thing. It doesn't capture z going to infinity. So these are going to kind of curve more in. It's not going to be this big of a gap. It should just be a line big. So that's going to be.
That's going to be z is equal to 0.
Y equal -0.
Or 3x.
Exactly. It's going to be that line y equal negative 3/5 x. Right? In fact, it's a little easier to see down here. Here. Because negative 3/5 x, see the jagged black line again? When x is -1, what would this equal? 3/5, which is 0.6. Right, so this is the line y equals negative 3/5 x. So we're seeing exactly what we saw from the equation. Of course we are in the graph. We're just not used to these kind of graphs. That's what I expect to see, some kind of a you're not allowed to go here image. Let me see, what did I want to show you up here? Oh, Jeff. All right. This ridge up here, that's kind of a nifty ridge. There's actually a ridge that is always, that's this guy. There's a ridge that's always infinity, because if you go along this ridge, the output's always going to be undefined, so it's going to be infinite. So that's where that going up forever. Right in the middle is that infinite ridge. Okay. So if I approached, to make this next connection here, the limit as x, y goes to 0, 0 of this. Obviously, it's an indeterminate form, right? if you know how to do L'Hopital's in two variables, which would involve partial derivatives. If you know that, cool, you still have to show me this. Here's how to do this problem. In fact, I want to give you, it's a little less vague than it sounds in the book. You can always figure out what the level curves are going to look like. In this case, they are lines, right? They are y equals mx. With me? So if you let y equal mx, what do we do? When we first learn limits, what did you first make that drove me crazy when I was a student? If I wanted to let x go to -3, you would go -2.8, -2.9, -2, and then go from the other side. And of course, you could only go from two sides. But now, how can I approach the point 0, 0? I can approach it along a parabola. I can approach it along an x cubed. I can approach it along the square root. I can approach it along freaking anything I want. Here, I'm going to approach it along the line, y equal mx. So then, what happens as x goes to 0? What happens to y?
Y goes to 0.
So are you all cool with the fact that I can now say the limit as x goes to 0? I don't have to write the whole damn thing. And replace y with mx. So I get 2x over 3x plus 5mx. So what happens there that's really nice? Thankfully.
You can factor out an x.
Yeah, the x's all cancel, right? My problem goes away. My problem is x, it goes away. So the answer is this. So the limit is 2 over 3 plus 5m. The limit is dependent on the m you choose. That's the whole idea here, isn't it? If I approach it along one line, I'm going to think it's this high. If I approach it along another line, if I approach it along the line y equal -x, how high am I going to think it is? 2 over 3 plus 5 times what?
-1.
-1? I'm going to think it's -1. Is it the height -1? If I approach it along y equal x, 2 over 8, so I'm going to think it's 1/4. So forth, right? And they're all right in a sense. They just don't go anywhere at the end. I just think a limit is what does it look like it's going to do, and in this case, it looks like it's going to do an infinite number of different things. So that's like, holy crap, the limit definitely doesn't exist there then.
So if the limit approaches 0, 0, we can always use y equal mx.
No.
Y equal x.
What would I have to do in this problem? Why would y equal mx really suck here? Because my problem won't cancel, right? So in that case, of course, what do I want to use? X equals my squared. So I didn't teach it this way last semester because I only came up with this idea later. But if you think about what the level curves are, that actually tells you what to substitute in here to prove that it doesn't have a limit there. The book, if you look at it, it makes it sound very vague. How do I know when to do what? And you can actually figure it out. Obviously, you got to make it on the same level as this. So I'm going to want my x to be my squared to make them on the same level, so they're like terms. But this is another way to do it when it gets a little freaky up here. So if I did let x equal my squared, in this case I want y, so that x equal to my squared. So I get twice my squared plus y squared over my squared minus y squared. So I get all my y squares cancel.
2m. And minus 1.
Cool. So the limit is that, again dependent on m. Therefore, since they don't all agree, the limit does not exist. So this is called the two-path test. You really only have to show two paths that come up with a different solution. I've just shown actually infinitely many paths, but you go ahead and show me if m is 0, blah, 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 if m is 1, blah, 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 they don't agree, therefore blah. Therefore, there is no limit there. The limit does not exist.
So for example, if we had that 2x plus y squared over x minus y cubed.
Yeah, if it was x minus y cubed, that brings in definitely a lot harder stuff to deal with. You can't make them all have the like terms. In that case,
But in the exam, we will have like terms that cross that in the exam.
Yes, exactly. Yeah, we're not gonna get too deep into this, thankfully. I mean, you can, that's just one way to make this harder. This is a subset of all the possible limit problems you could do in 3 dimensions, obviously. We don't want to get too deep into it. Remember what it was.
Two paths.
So real quick, just 2 more problems dramatic.
Well, you're trying to show that two paths are the same, but one.
No, 2 paths are different. 2 paths test. Show
You can't test.
2 paths different.
So any other value.
That's basically a counterexample, right? How do you disprove something? Come up with a counterexample. So if I think the limit exists, you say, no, there's 2 things that don't agree, it does exist. I just want to make sure you guys understand that they're not all going to be that horrible. What would I do here?
Solve for what?
Just plug them in. If there is no problem with the points, with my input, input it. So that still carries over. Don't go to all this weird shit if it's just plug the damn thing in and a number comes out. Right? So if we plug in 1, 2. The mistake people make, why would this be a mistake? This should still kind of work if you do it correctly. Why would that be a mistake? Or even just to make it even better. There, that's a little closer to right, but that's still definitely wrong. What's got to be true about any line that I use? And it was easy over there because I was going to 0, 0. My line has to go through the frickin' point that I want to get to, doesn't it? That doesn't necessarily go through 1, 2. So I'd have to make it like y equals m x minus 1 squared plus 2. I don't do that shit, obviously. You don't have to because it's just plug the damn thing in and it works beautifully. You with me? Second thing, real quick. Let's see if anybody freaks out. Can you factor this for me? And the answer is yes. So let me say it like this. Factor this. Let me give you a starting number. Factor it. It's not even letting it, just factor it. Yeah, exactly. Square root of x minus 2 radical y, square root of x plus 2 radical y. I'm not trying to be evil, but I wasn't. So what do you think you can do with this here? All the stuff you know from before is going to come back. I'll tell you honestly, you could obviously multiply by the conjugate. Remember that good old trick? Real quick, why would I do any work at all? Because when I plug 4, 1 in, it's an indeterminate form. So obviously, first plug the damn thing in and see if it's going to be indeterminate. Don't only plug it in the top or the bottom. Plug it in, make sure it's indeterminate. I mean, if the top goes to 3 and the bottom goes to 0, then that's obviously infinite. Right? But this stuff I could multiply with conjugate, or I could just factor this and then cancel the common guy out. Do you guys remember, like, multiply with a conjugate, or you could factor it, as long as you can cancel the problem. And the problem is this guy. And if I factor this,
take 1 away, get 1 on the bottom.
the problem goes away, right? Yeah. Wally,
Can we see another example with the m's?
with the what now?
With the m's?
Sure. Yeah.
What was the problem in the last?
Sorry? Oh, when you plug a 4 and 1 in?
No. The,
Oh, up here.
Yeah.
There wasn't any. That's why I just plugged it in.
No, that one.
No, this was related to this problem.
Oh, it was.
I want to make sure you knew how to factor this so you can do this the quick way. Yeah. Let me take one out of the book real quick. Yeah, so first off, check to make sure that it's indeterminate, so I know if I should do more work. And sure enough, it's 0 over 0. So I've got to do something. Most of us immediately think L'Hopital's, but trust me, that gets remarkably disgusting in this many dimensions. So think about how to match up.
Y square equals Q.
You don't want to just say y equals mx. Y is currently squared. How do you make it become something cubed?
3 over 2 plus
3 over 2. See, that's the kind of, just think about how to match them up so that they'll become like terms. You with me? And again, this is the part that's really hard for students to get down. We're in a plane. So what points can you plug in? All the points on this line, all the points on this parabola, all the points on whatever the hell this thing is. So you can use whatever path you want to. I'm going to be smart and use a path that makes it like terms. So when I plug in fact, let me be even a little smarter. So when I plug in, let me see, sorry. So as x goes to 0, x cubed minus, what's that thing squared?
MX cubed.
M cubed x cubed, right? Over x cubed plus m cubed x cubed. Thankfully, the section in the book, section in the homework says non-existence, use the 2 path to show that the limit doesn't exist. It tells you when to do what. So don't freak out and you're not totally on your own. What happens here? All the x cubes go away. So again, dependent on your m. Dependent on your m, you get different outputs for your limit. That's what tells you that the limit does not exist, because they don't all agree. They don't have all the same output.
So it's not
basically
dependent on
this
M
is
and
the-
M will cancel out.
Yeah, if we could do an example of, but yeah, then it would be the same no matter what m you picked, is the key there. No matter what m you picked, if you had one that actually did have a limit that existed, no matter what m you picked, it would be the same output.
So M would have to disappear.
Yes, m would either have to disappear or something else similar to that would have to happen, yeah.
Like say for example, x minus 4y, would it have
Let me let you guys go, and if you want to come up here, we'll try one out real quick. That works.
Nice eraser.
We have, all right, so we have.
Yeah, we just said that they were going to do that out.
Okay, so you let y go in there.
My chemistry class took 5 hours.
Yeah, that's what I was
During lunch.
What would it says something like 1, 2? Then you'd have to change that, huh?
Yeah, you have to change this.
1, 2 would have to be y equals y.
Just that.
Then it'd be yeah. Let's do, okay, cool. So let's do 1, 2.
Okay.
You like
So,
me?
let's see. The limit as x goes to 1, because as x goes to 1, y goes to 2, x minus 4 times.
So it's 1 minus.
Oh wait, what's this first?
Gotcha. That does work.
So we have x minus.
That does work. Yeah.
With me?
Yeah.
Okay.
That does work. Cool.
I don't know, do you
No.
correct? Okay.
Yeah. You mean the corrections, right?
Yeah.
Not yet.
No, I mean the, the exam, I had a good one.
The corrections, right? Or they were just pointing you back.
Yeah, they were just pointing it back to me.
Oh, but you don't have to make corrections though, right? Great. Why not make corrections or?
Yeah, I want,
Oh,
I
you
need
make the 100? No.
I made 100,
You can't,
grade.
okay. You can't get any points for corrections.
I,
As soon as I just gotta put it in the cap's computer.
okay, no problem.
Like,
No, I thought just one, like 1 point I can get back, or that's not possible.
Corrections you can get back up at most of 100. So if you score above 100 in the first place, you can't get anything back for corrections.
Okay.
Um,
No, because I missed one point because I don't know, it's calculating thing, it's like the square root of a number. I had all numbers correct, but I calculated from the calculator wrong. That's why I
oh,
lost
yeah,
that one.
okay.
So I thought about
See, I
getting.
figure if you make that high of a grade, you could probably figure out your mistakes without
Oh, yeah.
my motivation of point.